Good day! This session is intended for Grade 11 General Mathematics class. Welcome to Telemath Aralan, where learning continues on your respective homes. I am Teacher Ellie. This session will help you determine the intercepts, zeros, and asymptotes of a rational function. Knowing what a rational function is, you are now ready to learn its other properties. It includes recalling the meaning of intercepts, zeros, and asymptotes of a rational function, identifying the intercepts, zeros, and asymptotes of a rational function, and solving for the intercepts, zeros, and asymptotes of a rational function. In the previous session, you learned how to find the domain and range of a rational function. In this particular session, determining the intercepts, zeros, and asymptotes of a rational function will be done. Knowing fully the concept about the different properties of a rational function will be your guide to easily determine the behavior of a rational function.
Here is the graph of a rational function. As you can see, the graph intersected the x and y axis, and the points of intersection of the graph and an axis is called intercepts.
The intercepts of the graph of a rational function are the points of intersection of its graph and an axis.
Let's go back to our first graph. As you can see, the graph intersected the y-axis, and the point of intersection of the graph and y-axis is called the y-intercept.
The y-intercept of the graph of a rational function r of x, if it exists, occurs at r of 0, provided that r of x is defined at x is equal to 0. To find y-intercept, simply evaluate the function at x is equal to 0. Let us determine the y-intercept of this rational function. F of x is equal to 3 minus x all over x plus 1. As mentioned, that to find y-intercept, we simply evaluate the function at x is equal to 0. So, to find the y-intercept of this rational function, we will change the x value of the function to 0. So it will become equals 3 minus 0. We will replace 0 to x all over another x, 0 plus 1. We substituted 0 to x values of the function. We will simplify the fraction equals 3 minus 0 is 3, 0 plus 1 is equal to 1, and 3 divided by 1 is 3. So, the y-intercept of the rational function f of x is equal to 3 minus x all over x plus 1 is 3, or the ordered pair 0, 3.
Let us go back to our graph. As you can see, the graph intersected the x-axis, and the point of intersection of the graph and the x-axis is called the x-intercept. The x-intercept of the graph of the rational function is also called the zero of the function.
The x-intercept of the graph of a rational function r of x, if it exists, occurs at the zeros of the numerator that are not zeros of the denominator. To find x-intercept, equate the function to 0 or simply equate the numerator to 0. Now, let us try to determine the x-intercept of the rational function f of x is equal to x squared minus 3x plus 2 all over x squared minus 4. First, we will equate the numerator to 0. So our numerator is x squared minus 3x plus 2. And we will equate it to 0. Since we equated it to 0, we will factor x squared minus 3x plus 2. The factor of this x squared minus 3x plus 2 is, correct, x minus 2 and x minus 1 equals 0. So it will become x minus 2 equals 0, right? And x minus 1 equals 0. And we will solve for x. So here, automatically, by transposing negative 2, it will become positive 2. So x equals 2. Here, the same process. Negative 1 will be transposed here, so it will become positive. So x equals 1. So, the x-intercepts are x equals 2 and x equals 1. But by looking at the denominator of the original function, if we substitute 2 to the value of x, the denominator will become 0. The function becomes meaningless. So we will only accept the x-intercept at x is equal to 1 or 1, 0.
The zeros of a function are the values of x which can make the function 0. The numbered zeros are also the x-intercepts of the graph of the function.
Let us determine the zeros of this rational function. F of x is equal to 3 minus x all over x plus 1. To find the zeros of a rational function, we will equate the function to 0 or solve for the x-intercept of the function by equating the numerator to 0. So our numerator is 3 minus x, and we will equate it to 0. Alright? And solve for the value of x. So transposing positive 3, in this side it will become negative 3. So negative x equals negative 3 divided by negative 1 to eliminate the negative sign, and x will become 3. Thus, the 0 of f of x is 3. An asymptote is an imaginary line to which a graph gets closer and closer as x or y increases or decreases its value without limit. Asymptotes can be vertical or horizontal.
Here is the graph of a rational function with its vertical asymptote. As the y increases or decreases its value without limit, the graph of the rational function gets closer and closer. The vertical line x equals a is a vertical asymptote of a function f if the graph increases or decreases without bound as the x values approach a from the right or left. To determine the vertical asymptote of a rational function, first reduce the given function to simplest form. Then find the zeros of the denominator that are not zeros of the numerator.
Let us determine the vertical asymptote of this rational function. F of x is equal to x minus 1 all over x plus 5. It has been mentioned that to determine the vertical asymptote of a rational function, we will first reduce the given function to simplest form, then find the zeros of the denominator that are not zeros of the numerator. Since our given rational function has already been reduced to simplest form, let's try to find the zeros of the numerator and the denominator. Let's start with the numerator. So our numerator is x minus 1. X minus 1 equals 0. So x equals 1. For the denominator, x plus 5 equals 0. So x equals negative 5. The 0 of the numerator is 1, and the 0 of the denominator is negative 5. The vertical asymptote of this rational function is negative 5, since the value is the 0 of the denominator but not of the numerator. So negative 5 is our vertical asymptote.
Here is the graph of a rational function with its horizontal asymptote. As you can see, as the x increases or decreases its value without limit, the graph of the rational function gets closer and closer. The horizontal line y equals b is a horizontal asymptote of the function f if f of x gets closer to b as x increases or decreases without bound. To determine the horizontal asymptote of a rational function, compare the degree of the numerator n and the degree of the denominator d. If n is less than d, the horizontal asymptote is y is equal to 0. If n is equal to d, the horizontal asymptote y is the ratio of the leading coefficient of the numerator a to the leading coefficient of the denominator b. That is, y is equal to a over b. If n is greater than d, there is no horizontal asymptote.
Using the procedure on how to determine the horizontal asymptote of a rational function, let us determine the horizontal asymptote of this rational function. F of x is equal to 3x plus 8 all over x squared plus 1. So let us first determine the degree of the numerator. Our numerator is 3x plus 8. And the exponent of our variable x is 1. So the degree of the numerator is 1. And the degree of the denominator, x squared plus 1, the exponent of the variable x is 2. So the degree of the denominator is 2. So automatically, 1 is less than 2. Therefore, the horizontal asymptote based on the first guideline is y is equal to 0. This is our horizontal asymptote. Let us have the last example. Let's determine the horizontal asymptote of this rational function. F of x is equal to 8x cubed minus 1 over 1 minus x squared. So let's find the degree of the numerator. The exponent is 3. This is our degree, 3. And the denominator is 2. 3 is greater than 2. The degree of the numerator is greater than the degree of the denominator. Therefore, there is no horizontal asymptote.
DIY. Do it yourself. Complete the following table by giving the intercepts, zeros, and asymptotes of the rational functions. I will give you enough time to answer this, and your time starts now. Are you done? Let us see if your answer is correct.
I hope you have already learned how to determine the intercepts, zeros, and asymptotes of a rational function. Tomorrow, you will be solving problems involving rational functions. Again, I am Teacher Ellie, and this is Telemath Aralan.